All right, good morning, everyone. My project, my team and I decided to do our Python project to build a predictive model, which is a type of machine learning model for iris species classification. Now, to go more into what we'll be covering today and what we actually did for the project, I'm going to pass it over to Aika.
Thank you, Chad. Good morning, everyone. The objective of our project focuses on developing a machine learning model to classify iris flower species based on their simple and petal dimensions. This project uses Python and Flasks to build a real-time web application that allows users to classify iris species based on these inputs. We have key matrices for our project. This includes data sets, which is the iris dataset with the features like sepal and the petal dimensions. And we have value proposition plots, which is various visualizations like box plots and heat maps to understand features relationships, and model comparison, live demo. With this, I will pass to my teammate, Shaista.
Okay, thanks, Aika. So as Chad mentioned, our team is excited to introduce our iris species classification tool. What it is a web application that represents a significant leap forward in botanical, identification technology. So at its core, it's a tool that utilizes machine learning model developed in Python, and it's seamlessly integrated into a user-friendly web interface built in Flask. What sets this apart is its ability to provide instant, accurate iris species classification without requiring any technical expertise from the user. So with that being said, our target audience will be botanists, researchers, educators, and students who need quick and reliable iris identification. Imagine being able to classify an iris species in real time right from your browser. That's the power that our tool offers. So the benefits and features, it's going to be fast and accurate. It's going to give you those classifications, which is going to save time and reduce errors. It's a simple interface that Bhumika is going to demo for you later. And regardless of your technical background, it can be used effectively. What differentiates our application is its accessibility. So unlike traditional methods that might require specialized knowledge or equipment or access to databases, it's a web-based solution that delivers immediate results to anyone with an internet connection. So we've rigorously tested and validated our model to ensure its accuracy in the real-world scenarios, and the results are seamless, and that delivers a reliable tool. It's been consistent and will deliver consistent values to our users. So we're bridging the gap between advanced machine learning and practical everyday use in botany. It isn't just a technological achievement, it's a game changer for iris species classification. So as we talk about the validation and the testing, if we can advance to the next slide, we had to conduct our exploratory data analysis. And what this did was help us gain a bird's eye view of the data set that we started with. So it's essential to understanding the data that we plan to work with to ensure that our model and interface are built on a solid foundation. So in doing that, just to get a quick, like I said, bird's eye view, we use 3 key visualizations: box plots, pair plots, and heat maps. What the box plot is going to do, it's going to give you a quick view of feature distributions and variability across the species. It'll help you spot patterns and potential outliers. The next one is going to be the pair plot, which allows us to visualize relationships between features and observe how species can be separated based on those characteristics. Finally, the heat map will reveal correlations between the features, providing insights into those variables. So just very quickly, these visualizations ensure that we gain a comprehensive understanding of the data before we dive into programming, and it sets us up for a more effective and intuitive user interface. So as we gain that understanding of the data, Chad is going to review our logic and how we determined our machine learning and where we went from there. Thank you.
Thank you, Alma. I appreciate it. So for model comparison, we have two different classification models, which are two different types of machine learning models, right? We had k-nearest neighbors and logistic regression. So to evaluate how, quote unquote, well these models are performing, we use a technique, which is one of many, called tenfold cross-validation. And the metric we used, and again, there are many metrics, but we decided to use accuracy. So I think most people understand accuracy. You don't need a degree to understand that. The higher the accuracy, typically the better the model is. So we can see here both are performing pretty well. The k-nearest neighbors are 0.96 or 96% accuracy. Logistic regression is 0.95 or 95% accuracy. So we decided to choose the model with the slightly higher accuracy, which will be built into our UI, which was what relies on making the predictions. So the model we actually selected is k-nearest neighbors. Now to go into a little bit more logic, I'm going to actually show some Python code and to show how the model was built. And then I'm going to hand it over to Bhumika, who's going to show off the UI. So let me share my Python code. So before I start discussing, can everyone see my Python code? I can get some verbal confirmation.
Yes.
Great, thank you, I appreciate it. So when I first started, I imported many libraries. Some of you may recognize Pandas and NumPy. These other libraries are for the model building process. And if I didn't use these libraries, I would have to define these functions and do a lot of more work on my end just to get these to run. And these are already done for me. They have various functions and they're all very well documented. So why that's really important is when I run into errors, I can look and refer at documentation to try to figure out. So this is really a time saver and it's well documented and it helps my results to be reproducible. This code snippet here is loading the data. So we got the data set from a website. We did some data cleaning. So we needed to apply some column names and then some more data cleaning here as there's some empty strings. So we have to do a little bit of finagling with the data. With a couple of various, part of the EDA process where we could see some basic descriptive statistics. So again, just familiarizing ourselves with the data. You can see here in the lower right console, just trying to understand what's going on. Some of these code snippets here are what Alma showed in the presentation. So some various plots that we had. And again, all part of the exploratory data analysis process. Again, just trying to get a bird's eye view before we start doing the work. This code here splits our data. So some of the data, the purpose of this is to train the model, right? You're putting it through the model that will be used to determine how accurate it is, right? That accuracy thing, that accuracy slide I showed earlier. And then the other part, the subset that's not being used in the model, is going to be able to validate it. To pretty much, it's like quality assurance to check, is it really doing what it's supposed to be doing? So this code here is comparing two models, logistic regression and the k-nearest neighbor. And we're just running a simple for loop to perform this. So again, this is just a simple technique. And as you can see in the bottom right, the KNN had the 96% accuracy and the logistic regression had 95% accuracy. And as I mentioned earlier, we want to make sure this model is doing well. So right now we picked the KNN model, but we want to make sure it's doing well, right? We want to make sure it's doing what's supposed to be doing. So now we bring in the data that we didn't use in the model, which was about 30% of the data. And we can see the validation accuracy is also really doing well. So again, we do that just to make sure the model is performing how it's supposed to be doing. Because sometimes you can overtrain your model and that you can get wonky results, especially when trying to deal with predictions. Now to actually make predictions, I would have to go through doing a NumPy array entering values for sepal length, sepal width, and so on. Then I'll have to write this predicted class variable for the KNN model predictions. And then I can print it out. The predicted class for this particular data here is Satosa. But this requires some coding knowledge and some knowledge of what a KNN model is. And that's a lot of effort. And especially for someone who doesn't know this, that's going to invest a lot of time. So there's actually an easier way, which is where it comes to the UI. So I'm actually going to hand off to Bhumika, who's going to show you the UI and how this making predictions can be done a lot easier. So without further ado, I'll hand it off to her.
Thank you, Chad. Okay.
Say you actually had an English test. Sure, you studied, and it's a test, but it's a different test, right? So you're probably not going to do too well. So we had to fine tune the model just a little bit. So to get that accuracy actually down, which gets into the bias variance trade-off. But that was actually an issue because of the lower sample size that we have to deal with. But by reducing the split or actually increasing it, so what subset will be used in the validation process to do the quality assurance, if you will, that actually really helped. So that was a kind of a big issue at first because all of us were like, whoa, what's going on here? But we were able to figure that out through documentation and doing some research.
Very good. Question for you, Alma. Like, what are the key learnings from this project and how did you overcome those?
The key learnings for me were many, as a lot of the concepts were new. Even just what Chad mentioned, that was one of them for me. 100%. Yes, that means we're perfect. So let's keep moving. So a lot of new concepts. But as far as the actual programming, it was a lot of the libraries that I brought in for the visualizations, just practical application of some of the things that we learned in class, how easy it was to say, this is what I want to do. The documentation that was there I literally can Google, I want to create a pair plot. I may or may not understand what that is, but here's how you do it. And once I was able to do that, it was, like I mentioned in my part of the presentation, that bird's eye view. Even if I didn't understand why things were plotted the way they were, it was easy to pick out, hey, there's something going on here. Let me figure out what that is. And so it was very directional and helped me ask those questions of a mentor of mine once told me, you don't know what you don't know. So it started me down those journeys.
Very good. If like while you are working with this project, like how you and your team plan what to do, how to do, and when to do. Would you walk us through the process?
Okay, thank you. Yeah, from the beginning, the team was planning to do on different areas. Like, for example, I was planning if we can do on data analysis of certain commercial or business company, because I am from data analysis stream. Maybe 3-4 different topics, but finally we agreed on this one, which is very important and new, which assists us to understand the application of Python for AI and ML, which can be used for all streams, in quality assurance, data analysis. Even I raised how to sell our project, how to commercialize our project to get some income. So this project can be used for botany, who are working in plant sciences, maybe for governments, for NGOs, for any, or we can commercialize it. Nice. So we agreed and we learned a lot from this project. I appreciate the team who devoted to implement to do this project, and I learned a lot from this project.
Very
Thank
good. Very good. And Bhumika, like I saw you have developed like Steam. I'm assuming Flask and Steam together. What motivated you
Yes.
to develop that web applications and creating a nice user interface?
Yes. So as we start, once we finalize our project and we are meeting every day to discuss what we can do next, and we said we saw that our code are in Python. We can do this test and predictions in Spider also, but like I do not have that technical background, so I won't be able. Like it will be little challenging for the people who doesn't have a technical background to run the code in Spider. So then we decided to come up, let's build a web application. And yes, I missed your classes, but I did see the recording, and I saw one of the recording where you teach us how to build an application using the Flask in Python. So I go through that recording and we discussed that let's build a web application with that. And if we can do that, it will be user friendly for everyone who does know how to run the code in the Python.
Very good. Overall, you guys did a very good job. If you ask me, this is very quality project, and the overall presentation was wonderful. I would continue like this. Like if you ask me such kind of story, what you talk in interview, it will be compelling.
So this is our project called Student Report Management using Flask and Pandas. So basically, what is this project about? This project helps manage data student performance easily. So we use data manipulation and data collections in order to send it to Flask, and then Flask process it, and then we use a bar chart and in order to generate a PDF report with students. So this program is also helpful for example, schools and to generate a big data of students with different reports, different grades, and yeah. So what technology we use? So for the backend, we use Python Flask in order to send it with the HTML to the server. For the frontend, we use HTML, CSS, and templates to successfully send it to the Flask server. For the data storage, we use CSV files, and visualization, we use Python Matplotlib library, and deployment, we just use localhost and Flask server. And for the IDA, we use Visual Studio Code, and my teammate use Spider. So what is basically a Flask? So Flask is basically like a web server rather than user browser, and it uses so it's basically used for web development and to make customized projects, and it will run in a smooth pace. So how basically a Flask works? So you have a web server, and then clients send a request to that server. Then Flask processes the information, processes the input, and then it will generate URL and HTTP method. Then that HTTP message will go to the basically your HTML or JSON file, and then it will generate the client, the page for the new client. So here's the key features that we use in our project. So it's basically easy data management. So you can easily add, update, and delete new student records, including ID, name, marks, etc. Also, another one is automation. So it easily calculate student grades, generate an average grade at the same time in the app. Another feature is visual reports. So we use the bar charts using Matplotlib in order to generate understandable and easy charts within the program. Finally, we use PDF export. So it finally generates the PDF file where you can see the bar chart with the different students and their grades. So challenges faced and solutions. So there was a couple of challenges during our process. So one of this is handling missing templates. So how we can store the templates. So we just need to make sure that the templates are in the correct directory and we use the right path to that directory. Another one is data manipulation in CSV file. So it was kind of hard. So we used the Python Pandas in order to efficiently read and write the CSV file. And then for the rendering, we use the matplotlib to generate the bar chart in the PDF file. And now my teammate is gonna do the live demo for the project. Thank you.
Thank you, Nasari. Please stop sharing the code we used. These are the libraries we imported. This Flask to create web applications, and Pandas to manipulate the data in CSV. And this is matplotlib to create bar charts, and this library is to create PDF file. And here we are calling the functions, which is Flask class. We are calling it here. This is the CSV file name we are using to store the data. This function will create a CSV file if it does not exist already. Otherwise, if it created the CSV file for subsequent operations, it will use the same CSV file. Rest of the code I will explain at the end. Let me show the live demo. Now I am going to execute the Python file. This is the server created for that. Okay. Our project is a student management management project for the student. Here I'm going to give the enter 2 records for the student. Let it be student A. And student B. Student ID are 8 and 9. Let me show this data in the file. This CSV file is automatically created by Python. Here, the data is saved here, A and B. The total and average is calculated automatically using the Python code and saved in the CSV file for all the data we are giving. Now, let's do the other operations. I created the students A and B, right? Now I'm going to search the student. We can give student name or ID. So the student with name A as displayed here. I just created this student data for A. It is displayed here. Now I'm going to delete that student data, which is the ID is 8. Now let's search the same student data, which I have deleted. I think it's B or A. Yeah, that data is deleted. Now let's edit the data, which is B. A is already deleted. Yeah, I am going to edit this student data. This data is already in the CSV file, which is given already. Now I cannot change this student file, which is read only. Here I'm going to give it a C. I'm going to update the file. Let me show this here. See, the data is changed. The name is changed to C here. Also, when I click the data which is not in the CSV file, like H, which is not there, the student name is not there. When I click search, the result will show like no results found. It won't throw error. We can go back and continue the work, which is same for edit and delete. When we give the data which is not in the CSV file, it will show no student data found. We can go back and continue the work. It also generates the PDF file for the student reports, which is saved here. Yeah, this is for the, it shows the student name and average mark details for the data in the CSV file. Now, let me walk you through how this works. We use Flasks and Pandas to do this project. When I enter the student data here and click submit, the Flask will redirect to the Python function here. This is a Python code. Here, this is submit here. And here, the code will transfer the data, handles the submission and transfer the data to the CSV file. As I already said, when the CSV file is not there, it will create a CSV file. And if it's there, and it will save the data using the same CSV file. This is same for all function. When I click edit, this Flask transfer the redirects it to edit function. And the function is handled here by Pandas. Pandas is used to handle the data to CSV file. And this is when I click search, this function is the data, the control is redirected to search function. And when I click delete, here the function is here to do the operation. So how the delete works? When I click delete, the student's data is saved to data frame, excluding the student ID, which I want to delete. Now I conclude my presentation. Thank you. We are open to questions.
Good morning, everyone. We were supposed to be a team of 6, but now we are down to 2. Dana and I will present to you our Python project called AI Poem Generator. What is an AI-powered poem generator? It is a web-based application that crafts personalized poems based on user-provided themes or prompts. It leverages the advanced natural language processing capability of OpenAI GPT engine. It is designed to promote creativity, inspiration, and fun through the fusion of technology and literature. Now I'll pass on the presentation on to Dina to continue with the slides.
As we decided to do something fun, just to do something fun. And some of the key features that we were kind of focusing on is, you know, the poems that it generates is going to be tailored, you know, if you want to put input that, hey, I want to talk about trees, I want to talk about love or whatever. We wanted, and we wanted something, you know, a user-friendly interface, you know, soothing, just for the artistic minds, and to do it in real time, to do it right on the screen. So those are some of the features of our website, of our project. And now I'll talk about the end-to-end. Let me talk about the end-to-end architecture.
Sorry.
All right, so what we used the back end of Python, the Flask framework that we've kind of been talking to. It's been kind of common in this session, and we had a front end HTML, CSS, and then we used the OpenAI's AI engine, GPT mode, and then we're hosting it just on the local server. It's just calling our local server. It is scalable. We could put it on a production environment, but we did everything on our local environment. And so what happens, I'll just kind of, before we do our test drive, what happens is that you have the, can you go back? Sorry, I wasn't ready yet. So we have the web page, which is just the index HTML page that talks to our Flask is in the background listening and saying, hey, you need me, you need me, you need me. And so we have, we imported a logo on there. We're, again, we're interfacing with OpenAI, ChatGPT. And then it's going to update, because we wanted to do real-time updates. So it's going to give you the poem right on the webpage. And so that's kind of the end-to-end technology that we're using, the architecture that we're using. And if you go back, you can go forward. You were good. Why does it matter? We were trying to think of, again, something fun, something to do with, I'm really drawn to ChatGPT. I think it's going to run the world after a while, but I really love that the machine learning. I am a creative person, so I was really looking for something for creative writers, students, anyone that just you're trying to think of a poem for that special person. You can use our application in order to give you that story, that expression. So I am going to steal the screen from him.
Okay.
Are you able to see the index HTML?
Yep.
All right. So this is our poem generator. Again, we wanted aesthetically, it can take a little bit more work, but just something that was pleasing to the site. Say it with style. Again, we allow the user to put something in there. Let's talk about love is in the air. So let's talk about love and generate our poem. And so it thought about it. And so it came up with In the Quiet Corners of the Heart. And it went on, it completed. So it came up because I pressed it twice. So it was trying to catch up with my clicks. And so it came up with this as our poem. If I wanted to, let's refresh it and talk about, because it is cold where I'm at. Cold or snow. Let's talk about snow. And generate a poem about snow. In the heart of the winter's icy grasp, beneath the moon's ghostly clasp. So it just comes up. So something that was fun. And so I think that is, you can steal the screen back on,